Hey math kids, we're in section 9B and it's titled measurement, and we're just going to do one example here, I think. Yep. Example 2, and I have this drawing. There's a much better drawing in the book, so I would look there to see what this drawing really should look like. But it is a pyramid with a square base, and we're in 3 dimensions, and we're given all the vertices of the pyramid and all the information on the diagram. So part A says verify that the apex, in this case D, point D, lies directly above the center of the base. So to do that, we're going to find the midpoint of AC. So we're going to go across the base and make a diagonal on that square, and we're also going to find the midpoint of OB. And if they have the same midpoint, or if they have the same midpoint, that's going to be the center, and then we'll show that it's directly above. So just the Z value should be different. So let's do that. So if we find the midpoint of OB, that's going to be, this is the origin. So we're going to say the change, or adding those together. So 0 plus 4. So I'm going to write this out because I think it'll, so there's the origin. So we take this x value and this x value, add them together, divide by 2. Then we take this x value, this y value, and this y value, divide by 2, y and y. And that's going to be the midpoint. And if we simplify that, that's going to be 4 over 2. So that's 2, 4 over 2, 2, and then we get a 0. Okay, now similar thinking, we're going to go from A to C this time. So we want the midpoint of AC, and with that we're going to do 4 plus 0. Then we're going to do 0 plus 4. Then we're going to do 0 plus 0 all over 2. So we get 4 halves, which is 2, 4 halves, which is 2, and then 0. Okay, those are the same, so that really is the center right there. And if we look at the value of the apex, see how the x values are the same, the y values are the same, and then the z value, because we're at 0, we just raise up to 5 to get to the apex. So that's how we prove that one. Now part B says find the volume of the pyramid. So volume of a pyramid is 1/3. Volume is 1/3 times the area of the base times the height. Let's see, how do I write that? Let's do area of the base times the height. So since the base is a square, and we know each side is 4, because from here 0 to 4 right here, if we just look at the y values change right there, it's 4. We're told that it was a square, so we're going to say 4 times 4, and then we're going to multiply that by the height, and we know that our height is 5, because we know this from our previous one. We knew the center was from 0 and it raised up to 5 right there. And we take 1/3 of that. Now if we just multiply all of those out, we're going to end up getting 80 over 3 units cubed. So the volume is 80 over 3 units cubed. Now we're moving on to the next part, part C. It says suppose M is the midpoint of BC. So right here's M, it's the midpoint, which means that this and this are the same distance. And it wants us to do 3 different things. So first it wants us to find the coordinates of M. So to do that, we just need to do the midpoint formula again. Let's see, let's get this color. So I'm going to do that up here between these two. So we just add the x's together. 4 plus 0 is 4. Cut that in half. Then we add these together, we get 8. Then we add those together and we get 0. And so if we simplify that, we get 2, 4, 0. And so that is the midpoint, or actually, that's just M. We already have a name for it. Okay, now we want to find the exact length of MD. So MD is going to be from here to here. Okay, and we're just going to use the distance formula using these two things right here. So when we do the distance formula, we find the difference between the two. So I'm going to do M minus D. So 2 minus 2 is 0 squared. And then 4 minus 2 is going to be 2. Then we square it. And then 0 minus 5 is going to be negative 5 squared. This is all under a square root. So 0 squared is just 0. This is going to be 4 plus 25, which is the square root of 29. So once again, the exact length of MD, or this purple segment right here, is the square root of 29 units. Now we have one more part. It says, hence, find the surface area of the pyramid. So surface area, we're going to add these triangular sides. There's 4 of those. So area of each triangle times that by 4, and then we're going to add that to the square area of the square base. Okay, so to do that, we need to find the area of just one of those triangular sides. So if we look at B, C, D, so I'm taking this face. We have our M, which is going to tell us our height. And the area of the triangle is just going to be 1/2 base times height. So our base is the distance of BC, which we can't remember. Did we just find that? Is that the last thing we found? No, that was MD. So MD is the height, so I'll write that in. So this is square root of 29. And the base right here, oh, the whole base is one of the sides of the square. Okay, so that's 4. And so we just have to do 1/2 times 4 times square root of 29. This will reduce to just 2 square root of 29. So the area of this triangle, which is the area of one of these triangles, is 2 root 29. So that's going to fill in right here. So we have 2 root 29 times 4 plus the area of the square. And the area of the square was just 4 times 4. Now we just need to simplify it. So 4 times this would be 8 root 29. 4 times 4 is going to be 16. And let's get a decimal answer for that. So I'm going to say 8 second square root 29 plus 16. We end up with 59.1. And it would be units squared. So that is the surface area of the pyramid. If you need additional help, please come to Math Lab. Until then, calculator.